All right, geometry crew, we're moving on to chapter 12. Section 12.1 is all about tangent lines. All right, this entire chapter is about circles, so we're going to be learning a bunch of different facts about circles, different theorems and formulas. This first section, though, about tangent lines is actually pretty easy. And I'm going to do the first three problems on page 766 for you. All right, make sure that you do understand the theorems that are in this section. All right. It's very important to know, especially any tangent line to a circle. All right, so if we have a circle, all right, and then we have a tangent line, which is just a line that touches the circle at one point, all right, that point where the line, the tangent line is touching the circle, all right, then the line is perpendicular to the radius at that point of tangency. So this is perpendicular, okay? And they're going to be telling us to do a lot of things here. Because we know this is perpendicular, we can now create right triangles, all right? And they'll ask us questions about that, all right? So that was theorem 12.1. Theorem 12.2, it says, if a line in the plane of a circle is perpendicular at the radius, then you can say it's a tangent. So that's basically very close to it. Well, it is the converse of theorem 12.1. So you can just say it, frontwards, backwards. And then the last theorem says that if two tangent segments to a circle share a common endpoint outside of the circle, then the two segments have to be equal. They have to be congruent. So they say if you have a circle and you have a point outside of the circle and you construct the two tangent lines to that circle, all right, from this point to here and then from this point to here, those are congruent line segments. Okay, that's what that theorem says. And that'll come into play with a couple of the later problems in this section. But I want to do the first three problems just so you have a good idea of what we're doing today. All right? And they draw a diagram. All right? So there's the circle. And we have the center of our circle is point A. And they come out to point B. So that's point B. And then basically what they're doing is constructing a right triangle. And they actually give this a point. That's point D. All right. So with this diagram, this is what we're using for these three problems. So it says, the first one's super simple, all right? The first one says, if the measure of angle A is 58 degrees, so if this measure is 58 degrees, they want to know what is the measure of angle ACB. So basically, this angle right here, they want to know that measure. So they say angle A is equal to 58 degrees. Well, we know that angle B is 90. So we can solve for this angle C down here just by subtracting, 180 minus 90 minus 58. That will tell us the angle measure for angle C. And angle C is 32 degrees. All right? So using this same diagram, let's look at number 2, problem number 2. It says if B is 8, if BC is 8 DC is 4, then what is the length of the radius? Okay? So I'm going to come up here and I'm going to write this in pink. So BC is 8. So I know that this line segment here is 8. And they tell me the distance from here to here is 4. Okay? They want us to say what is the radius, which is the distance from A to B. It's also the distance from A to D. You can call both of those line segments X because they're exactly the same lengths. All radii inside of the same circle are congruent. All right? So we're going to use Pythagorean theorem. So we have x squared plus 8 squared is equal to x plus 4. We need this entire hypotenuse. So it's x plus 4 squared. We're going to have to FOIL that. Remember that from Algebra 1? All right? So we have x squared plus 64 is equal to, well, when we FOIL this, we're going to have x plus 4 times x plus 4. Remember first, outer, inner, last? So x times x is x squared. X times 4 is plus 4x. 4 times x is plus 4x. 4 times 4 is plus 16. All right? So we have x squared plus 64 is equal to x squared plus 8x, I'm just going to combine those, plus 16. All right? The x squareds, if I subtract the x squared on both sides, these are going to cancel. All right? So I'm going to subtract 16 on both sides. All right? And when I subtract 16, I get 48 is equal to 8x. All right? And you divide by 8 on both sides. X is equal to 6. So I know that the radius, both of these line segments are 6. All right? And that would make sense because if I do the Pythagorean theorem, 6 squared plus 8 squared is equal to 10 squared. That's a Pythagorean triple. Okay? All right, let's look at number 3. If AC is 12 and BC is 9, what is the radius? Okay? So, number 3. If AC is 12, so this entire line segment, all right, is 12. BC is 9. So this is 9, no longer 8, okay? What is the radius, which is x? Once again, Pythagorean theorem. X squared plus 9 squared is equal to 12 squared. 12 is the hypotenuse. So we have x squared plus 81 is equal to 144. All right, and then we're going to subtract 81 on both sides. So we have x squared is equal to 63. All right. Take the square root. All right, so we have x is equal to the square root of 63, which is about 7.9. So that's your radius is 7.9. All right. Now, I quickly wanted to look at problem number 18. All right. Problem number 18, which is also a homework problem. They give you this circle and they construct these tangents All right, it's something like that. But they tell us in this problem that, for instance, like this line segment right here, all right, they tell us that line segment is 9. Okay? And then they tell us that this line segment right here is 6. And then they tell us that this over here is 8, and this over here is 16. And they want to know what is the perimeter of this quadrilateral going around this circle. Well, this takes into consideration theorem 12.3. Remember, if you have a point outside of a circle and then the two tangents from that point to the circle, those line segments are going to be congruent. So if this is 16, this is 16. If this is 9, this little bit over here is 9. All right? If this is 8, then this little bit over here is also 8. And then this would be 6 because that's 6. And then you just add up all of those numbers. Okay? So I wanted you to take a look at that kind of a problem, but that's how you do it. All right, hopefully everybody's staying healthy, and have a great weekend.